The next section is example. Before we go to this example, I like to move back to this we can combine this equation for the hydrodynamic force to this equation. The force is equal to combine the term to get this. Okay. And the question is these are the gravity dams. Using below data, determine the normal load and abnormal load provides dam cross-section in the below figure. And in our condition for the dam, we have to check many cases. For the first case is if the reservoir is full, no tailwater, uplift consider, and drain working. Okay, so from this given information, for example, the RL reference level of the depth is 100 meter. So this we fix this is a foundation level, okay, and reference level of the roadway at the top of dam is 161. So that is the level of the road of the top of the dam. Maximum pool level is 152. That is the pool level 152. Maximum tailwater 123.9. So this is maximum tailwater. But in our case, we assume 0 because there is no tailwater. And location of the concrete gallery is 7 meter from upstream face. So in this case, we use the this is the grain and grain gallery about 7 meter from upstream face. And road width at the top is 6.1. So this is 6.1 road top. Downstream vertical face up to 154. That is the level that this is downstream vertical face. And for the upstream face is vertical, so it is upstream face vertical. And downstream face of the dam is 0.9 to 1. It's the 0.9 horizontal to 1 vertical. Okay. Density of the silt ladder water, that is for the sediment, density of the sediment, weight of concrete 2.4. Safe bearing capacities for the stability checking. Okay. And shearing stress at 21. And for allowable friction factor under abnormal load is 5, and for normal is 5, abnormal is 4. And maximum coefficient of sliding, so we can, for the next lecture, we give more explanation about this factor to check the stability of the dam. And for the holistic coefficient, and this is the alpha horizontal, okay, is 0.9 and upward. And for the vertical seismic coefficient is downward. So that is the upstream, not this way. It's upstream. Alpha is upstream and alpha V is downstream. We can write like this for okay. Next, we can start to calculate the vertical force and horizontal force. So in this case, vertical force is, we assume that it's downward is positive, and for the horizontal force is downstream is the positive. Okay. So we can calculate for the weight of the concrete. We divide to W1, W2. Okay, and we use the unit of this weight is the 10 power 3 Gn. So we use the specific weight of concrete 2.4 ton per cubic meter. Okay, and initial force due to the earthquake. So we just in this case we we can write the direction of the of the force. For example, in this case, because of the earthquake, horizontal earthquake is upward, so we, for the initial force, it's opposite to the alpha h. So okay, this is and from the this one PEH, okay, initial force is on this direction, and for the vertical force, see the vertical force, because of alpha v is up downward, so we expect that PEV is upward, P1 upward, okay, and because of its downward, so we expect that PWEV is this direction, okay. Okay, after we draw the free diagram of the force, and especially for the initial force finish, so we can do calculation and put in a table, okay. See, for the initial force for the PEV, in this case we time the acceleration point 1 is a negative 407 because of is upward direction, okay. And for PEH is the on the downstream direction, so it's positive, okay. PEH B1 B2. For the water hydrodynamic pressure PW, okay, is the downstream direction and initial force due to the vertical earthquake, okay. So this is the upstream direction, so we put in a negative, and the hydrodynamics force due to the earthquake PH, okay. So we can find the FE is equal to 286 in the downstream direction is positive, and it's for the uplift force U1, U2, U3. Is the a vertical direction, so it's all negative sign. And if we combine the force, the downward force is about 4,069, and vertical force is the 1,064. Okay, that is summation for the horizontal force is 2,315.